Hello everyone. In this video I will discuss about how to plot the ferroelectric hysteresis loop. The loop is simply known as the PE loop because we plot the data between the polarization and the electric field. So simply we can call the loop as a PE loop. Initially I will discuss that since we receive the raw data from the machine, which is mostly in the form of Excel file, ASCII file, or sometimes in the notepad file as well. It depends on the machine and the raw data that we receive in the format. So initially we will receive the raw data and then we will reprocess the data and convert the basic unit and select the suitable columns from the raw data. And then we will plot the PE loop, and from the loop we will extract some information regarding some basic parameter of the PE loop. Regarding the information that we can extract from the PE loop is the saturated polarizations, the corrosive fields, the remnant polarization, and also we can describe the nature of the material based on the PE loop. So these are some basic information that we can extract from directly from the PE loop. So basically on these parameters, when we extract the saturated polarization, which is also known as the maximum polarization, we will extract from the loop directly, and then we will see from the loop that what is the value of the corrosive field and the remnant polarization. And then based on these parameters, we will extract and we can calculate the recovery energy density as well as the total energy density and the efficiency of the sample. So now coming towards the plot, I will show you that we will plot the data that we receive as it is from the machine, and then we will plot the PE loop. Now we will start to analyze the data that we receive as it is from the machine. Since we receive the raw data of the pristine barium titanate, and this is the data that we collect at different electric field. So the raw data that we receive at 1 kilovolt per centimeter, 5, 10, 20, 25, 30 and 40. So we will analyze the data that we collect at different electric field. I will start from 1 kilowatt. So here we can see that we receive the data in the form of notepad, and there are 4 columns in the data, but we will only select the electric field and the polarization column. So from here I will select all the column, and then I will open the origin software, and then we will paste the data here. However, we will delete the first and last column, which is the area and time. And now we will left with the electric fields and polarization column. So on the x-axis we have electric field, and on the y-axis we have polarization. So we will rename the column with E and P stand for electric field and polarizations, while here we will put the units, but we need some unit conversion as well because we receive the electric field data in the form of volt per meter, while we receive the polarization values in the form of coulomb per meter square, which we need to convert. But we will do the conversion later on directly in the data, and now we will just put the unit here directly, and then later on we will convert the unit. So these are the units of the electric field and polarization. Now just select and plot the data. So we receive the data like this. Since as I told you we need to convert the unit, so for electric field conversion we need to divide the value by a factor of 10 power 5 to convert from volt per meter to kilovolt per meter. So now we already convert the unit from volt to kilovolt per meter, and similarly we need to convert the unit of the polarization. So simply we need to divide by a factor of 100, sorry, not 100, divide by 0.01 to directly get the polarization value in the form of microcoulomb per centimeter square. And similarly we will do it for the rest of the electric field as well. So now I will open the raw data received at 5 kilovolt. So this is the raw data received at 5 kilovolt per meter. So I will do the same. I will select the raw data and paste it in the origin, and will do revise the same by deleting these two columns, which is extra, and then again we will rename it, but this is the data that we receive at 5. So I will just rename it from here, that this data is received at 5 kilovolt per centimeter, and similarly for the rest as well. So we will do it the same for all of the electric field data. So now I will just go directly to the 40 kilovolt per centimeter data, and I will select the raw data, and then similarly we will paste it here. So again we need to delete these two extra columns from the data, and then just put these extra cells, and this is the data received at 40 kilovolt per centimeter. Just rename the data from here, and this is also x-axis and this is the y-axis, or simply one is the electric field and the second is the polarization data. So now we have three data set: data received at 1 kilovolt, 5 kilovolt per centimeter, and 40 kilovolt per centimeter. So now we will plot the PE loop, and we will see how we will plot the data. So just select all the columns, x-axis as well as the y-axis data, and then plot it. So now the data looks like this, because we plot the 40 kilovolt with the 1 kilovolt per centimeter, which is quite less, but from here we will convert the unit, and then we will see. So again do the same thing, divide by 10 power 5 to convert the units. Now we convert the unit, and then from here do the same thing, and divide it by a factor of 0.01. So this is the data. We cannot see the 1 kilovolt data. However, if we plot the whole range, then we will see all the data. Now how to collect the information regarding the saturated polarization, the maximum polarization, as well as the recovered energy density. Just drag these two lines, and then you will see. So we can say that this is the maximum polarizations for the 40 kilovolt. So the maximum polarization is almost around 11.69 microcoulomb per centimeter square. While if we talk about the corrosive field, so this is the corrosive field, because here at this point on the x-axis, sorry, this is the remnant polarization, because on the x-axis we have zero polarization on the y-axis, and but still we have some values of the electric field. So this field is known as the corrosive fields. And if we talk about the remnant polarizations, this is the polarization that left in the material when the electric field is 0. So this is simple. You can collect all the information: its saturated polarization, corrosive field, as well as the remnant polarization. In simple word, I can say that saturated polarization is the maximum polarization that we receive when we further increase the electric field, but the polarization remain constant. And in simple words, the corrosive field is when the electric field is not 0. However, on the y-axis we have 0 polarization. So this field, which is almost 15.39 kilovolt per centimeter, is the corrosive field, while this value is known as the remnant polarizations, because at this point we will say that the electric field on the y and the x-axis is 0, while still we have some polarization. So this is known as the remnant polarization. Thank you so much. If you have any question, please write it to me. And in the next video, we will discuss about how to get the information regarding the total energy density efficiency as well as the recover energy density. Thank you.